You're listening to the Agentic Engineer podcast, weekly AI agent intelligence for builders. I'm your host, and with me as always is my co-host. Let's get into it. Issue 27. Honestly, this one has teeth. Model pricing forced a routing conversation nobody wanted to have.
And Linus Torvalds basically called the entire AI industry soft. So there's that too.
Yeah, we'll get there. TLDR first. 3 things happened this week that matter. 1. Fable 5 is Anthropic's most capable model and only 8% of their revenue. Opus 4.8 is doing 28%. That gap is a routing signal, not a complaint.
Meaning the most capable model in production history is the one everybody's routing around.
Exactly. 2. AgentCore Payments hit general availability this week. Agents can now autonomously spend money. Real transactions, production infrastructure. 3. OpenViking from ByteDance Valk engine cut input tokens 34 to 91% on benchmarks.
34 to 91. That's a wild range. What's the catch?
We'll dig in. Let's start with the big one. The routing playbook. Drew Brunig mapped the Fable 5 pricing story to Moore's Law, and it's the right frame. Single-threaded clock speed stopped doubling in the mid-2000s. Developers had to explicitly think about cores. Most resisted until the financial pain made it unavoidable.
And now we're at that same inflection point with models.
Right. Fable 5 costs 9x, with GLM 5.2 cost per token. The RAMP AI index covers 70,000 companies' actual spend. Fable is 8% of Anthropic revenue, despite being the frontier. The market already routed around it without anyone building a routing layer.
Okay, but here's my issue with that framing. You're describing something that happened organically. Teams chose cheaper models. That's not a routing layer. That's cost avoidance.
There's a difference. Cost avoidance is reactive. You get the bill, you switch. A routing layer is proactive. You decide ahead of time. Design thinking gets Fable. Code generation gets Opus or GLM. Batch extraction gets Qwen. Intentional, not accidental.
I've heard this argument for 3 years. Hybrid model routing. Tiered model selection. It never actually ships.
It ships when the price delta makes laziness expensive enough. When the gap was 2x, you could rationalize it. At 9x, you cannot.
Fine. But most teams are still one model wired into everything. A 9x price differential doesn't write the routing logic for them.
No, but it writes the motivation. The architecture follows when the financial pain is specific enough. It always does.
OpenAI went the opposite direction this week. Sol underperformed at launch, so they cut price 20% on input, 33% on output through November. One company forces routing decisions through high prices, the other undercuts to avoid them.
Which is actually the same signal read differently. Capability and adoption are different curves. Sol is capable. The adoption wasn't there at the original price, so they moved the price to close the gap.
Kiro gets the full GPT 5.6 family now. Sol, Terra, Luna. Terra is the one worth watching. Terminal Bench 2.1 showed roughly 82% cost reduction on completed tasks. That ties directly into this routing story.
Terra is the mid-tier slot. An 82% cost reduction on completed tasks is a real number. Terminal Bench 2.1 is actual coding work, not synthetic. That's a model designed to eat the long tail of code generation. Exactly where you want to route things off Fable. Quick hits. AgentCore Payments is generally available.
Agents can spend money. That sentence should unsettle people at least a little.
The protocol stack is X402 for paper request, machine payment protocol for agent-to-agent transfers, and Coinbase Bazaar as a curated MCP server of pay-per-use API points. There's an up-to cost cap scheme for dynamic transactions. You set a ceiling, the agent authorizes up to that ceiling without asking.
Which means someone has to set those ceilings thoughtfully. And most people won't.
Fair concern. Quick create provisions Coinbase credentials from a console, which lowers setup friction. But the policy design is entirely on the operator.
This launched quietly via AWS. What's new? No press tour. The Agentic economy just arrived, and the announcement read like a minor feature update.
There's no meaningful distinction between an agent that's a flight and one that pays for an API call. The second is now production infrastructure. It just didn't get a keynote. Fabien Sanglard published his agent.md. If you've read his Quake or Doom 3 code archaeology books, you know the quality bar. He spent months on real coding sessions and distilled the rules that actually changed output quality.
What ended up in it?
No magic numbers. Early returns over nested conditionals. Private by default fields. Function names under 30 characters. And never touch code blocks you didn't write.
That last rule is the interesting one. The agent stays in its lane, doesn't rewrite things it wasn't asked to touch.
He built it because he was tired of re-explaining the same constraints every single session. Context windows have no memory across sessions. His agent.md is institutional memory for a system that technically has none.
314 HN points. Not viral, but the right audience saw it. Builders read it, published their own versions. It's a pattern now. Your codebase gets an agent. MD before it gets a README update.
Apache Maka, an agent workspace built on an append-only execution log. Every model message, tool call, result, permission decision, immutable fact on disk.
So basically a head log for agents.
That's exactly what it is. The agent reads full history or a summarized version. Neither mode deletes the underlying record. Crash recovery and session branching sit on top of that log.
Apache incubation is the actual story here. Solo GitHub repos building agent runtimes are everywhere. Apache backing means enterprise procurement teams can say yes to it without a 6-month vendor review.
And agents that recover from crashes without losing state are categorically more reliable than agents that can't. That's the differentiator. The log is how you get there. Paper breakdown. Anthropic ran a protein binder design campaign using Claude Mythos Preview and Opus 4.8 against 15 targets. They succeeded on 14.
What's the baseline? Is 14 out of 15 impressive or expected?
Individual binder success rate was 22 to 35%. Industry baseline is 10 to 15%. Several binders hit binding affinity tighter than the best published result for that target. So yes, genuinely impressive.
Okay, that's a real result.
The more immediately useful result isn't the campaign, though. It's Opus 5 analyzing raw NMR spectroscopy and LCMS data from a contract lab. 2-sentence prompt, 23 minutes. Matched expert analysis, 96.4% versus 96.33%.
Wait, that's a much broader story than drug discovery.
Much broader. If the model takes raw instrument output and matches expert analysis, that pattern extends anywhere structured analytical data exists. Materials characterization, QC labs, environmental monitoring. The narrow framing undersells it.
Paper was 8.8x compression, 35-minute paper into 4-minute read. What's missing from the story?
The campaign took months and covers one protein class. No data on failure modes. No edge cases where confidence exceeded accuracy. Nothing on less common target classes. One successful campaign is not a production story. Mythos is still gated anyway. Opus 5 is what you can use today. Tool of the week. OpenViking. ByteDance Volk Engine. The core idea. Agent memory as a browsable file system. Memories, RAG chunks, skills, each gets a Viking. / URI.
That URI scheme is doing work. Why not just a path?
Because the tier matters. L0 is a 1-sentence abstract, about 5 tokens. L1 is a paragraph overview. L2 is full content. The agent navigates to a URI and chooses how deep it loads. Most tasks only ever need L0 or L1.
And that's the 34 to 91% token reduction. You're not loading full documents unless the task actually requires it.
Right. On LocoMO user memory accuracy benchmarks, it lifted scores from the 24 to 57% native range up to 80 to 83%. Task success on Tau2. Bench rose 6.87 percentage points. The benchmarks come from real evals, not synthetic setups.
32,000 GitHub stars plus almost 4,000 this week. ByteDance is serious about this one.
Caveats. Self-evolving L0 abstract updates are experimental. The model updates its own summaries as evidence accumulates, but that feature is not production hardened. Core tiered loading is solid.
I want to flag that 34 to 91% range though. A result that wide usually means the improvement is highly task-dependent. What's the 91% case versus the 34?
The 91% case is probably a task with a lot of context the agent doesn't actually need, large memory stores where L0 is enough. The 34% case is tasks where the agent genuinely needed to go deep. The architecture is sound, the ceiling is real, but don't expect 91% on everything.
Pip install OpenViking. What does setup look like day one?
OpenViking server starts the local server. Then OVLS to browse context like a directory. OVFind for semantic search. OVRead for full content. OVAbstract for the 5-token L0 summary. CLI first. Works like a file system command set. Entry cost is low. Agent index. N8N picked up 1,291 stars this week. Biggest single week gain in the entire index. Not obviously tied to a specific launch.
What do you think is driving it?
MyRed, the model routing conversation. N8N sits at the intersection of orchestration and workflow automation. It's where routing logic actually gets implemented. Teams think about routing end up looking at N8N. The story this week may have sent people there.
LangGraph at plus 497 continues the sustained climb. Now within 12,000 of Llama Index from a much smaller base.
Kiro Crew added 251 from a 2,956 star base, growing at roughly the same rate as MS Agent Framework, which added 239 from a base 4 times larger. Proportionally, Kiro Crew is running hot for its size.
Flowwise at plus 12. Essentially flat. The no-code agent builder category is consolidating, not growing uniformly anymore.
OpenClaw plus 785, up to 387,287 total. Steady week. Hot take. Linus Torvalds used AI to debug a DRM/XEVRAM flat CCS allocation bug in the Linux kernel. The AI declared impossible and unsolvable. Multiple times. He pushed through anyway.
And fixed it.
Fixed it. Commit message. I suspect those things have been trained by people who may not be quite as stubborn as I am. That is not a compliment. It's a diagnosis of how sycophantic training works.
I want to push back, though. Sycophancy gets treated like it's always bad. But not every user wants a model that argues with them. Sometimes the agreeable response is the correct product decision.
There's a real distinction here. Agreeable on preferences, fine. The model mirrors that you like dark mode, fine. But agreeable on technical facts when you're 3 retries deep on a genuinely hard debugging problem, that's a failure mode with a name. It's learned helplessness, formalized into the weights.
Sure, but the workaround the hot take implies is be more like Linus. Be more stubborn than the AI. That's not a product solution. Most people aren't Linus Torvalds.
No, and that's the point. The best agents keep going when a human would stop. The kernel bug is the canonical example. A human would have backed off on impossible. Linus didn't. The model should have been the stubborn one. Right now it's doing the opposite.
We're mostly building models that optimize for conversation going smoothly, which look like helpfulness until you hit a genuinely hard problem and the agent taps out.
And most teams building agents haven't confronted this yet because their tasks aren't hard enough to surface it. The kernel debug is an extreme case, but the gap is real.
Think about it before your users blame the agent. That's the practical takeaway.
That's a wrap for issue 27 of the Agentic Engineer podcast. Subscribe to the newsletter at theagentecengineer.waltsoft.net and follow us on YouTube at the Agentic Engineer Pod. Share it with a friend who's building with agents. We'll be back next week. Until then, keep building.